Hello and welcome back. In this segment, we are going to talk about profit maximizing behavior of a perfectly competitive firm. And before we start that conversation, we're going to talk a little bit about the assumptions that are kind of underlying this perfectly competitive market framework. And that is the, again, fancy name for the market model of supply and demand. Recall in this model, we have many buyers and many sellers. In fact, we have so many buyers and sellers that each one, is like a drop in an infinitely vast ocean. And the goods that are being sold are the same. We call these homogeneous products. Firms, if they want to, can freely enter or exit the market. There are no barriers to entry, things like intellectual property rights or other sorts of property rights over an input, perhaps, that would prevent other firms from entering the industry. And the implications of 1 and 2 here in terms of these assumptions under perfect competition is that because there are so many buyers and sellers, that really dilutes the ability of any one buyer or seller to actually negotiate or exert market power on the price. And remember that term market power, because we're going to talk quite a bit about it moving forward. In this model of competitive market power, okay, there are so many buyers and so many sellers that no individual agent is able to negotiate the price. They behave as what we refer to as a price taker. And again, that's an implication really of these two assumptions here. Number 1 and number 2, the goods are exactly the same, and we have a very, very big market, such that no individual, no buyer or seller can affect the market price of the good. So moving along, we are going to define a few concepts related to revenue, and the way we're going to think about approaching the characterization of profit maximizing behavior from the firm's perspective is to essentially look at a marginal cost benefit analysis, where the total benefit from a firm in terms of selling goods or services, we know that is the total revenue. Okay, but there is a cost that we have to net out of that when we compute the profit, which is the firm's underlying goal, right? Is to maximize profit. We talked about that in an earlier segment. If we were to take the total revenue here, which is the price per unit, assumed again to be constant from everybody's perspective because they do not exert market power. So it's the price times the quantity sold or quantity traded. That is the total revenue generated or the total expenditure from the consumer's perspective. And if we wanted to know what the average amount of revenue was, we could take the total revenue divided by Q, and you'll notice by definition here, since we're selling every unit at a constant price P, that the average revenue is also P dollars. Now, if we were using some sort of different pricing scheme, or maybe we offered some sort of quantity discount, the second bullet point wouldn't necessarily be true. So this is absolutely sensitive to this assumption that because the firms don't exercise any bargaining power, they can't really use creative pricing tactics. The price is just constant. And no matter if they produce a little, no matter if they produce a lot, because they have no market power, because they're a tiny drop in an infinitely vast ocean, they have really an insignificant or a negligible effect on the total market output. The other important metric we're going to talk about here related to revenue is something called the marginal revenue. And you're hopefully thinking, well, we heard marginal cost before. I know anytime we hear marginal, it has to do with that last unit. And the marginal revenue here you could think of as the revenue generated from selling one more unit, but it represents the change in the total revenue with respect to the change in quantity sold. Okay, and what we're going to do next is just take a look at a little exercise here to apply the definitions in some mathematical context. All right, so let's take a look at an example here where we are given the quantity purchased schedule. So that is Q. So this first column here, Q, is the quantity sold. The P column is the price being charged, and you'll notice in this example here that the price of every single unit is the same. It is constant at $10, reflective of that fact that no matter if we try to sell 1 unit or 1,000,000 units and maybe try to drive the price down for whatever reason, we can't do that because as a firm in this model, we do not have any ability to affect the price. We don't exert any negotiating power, no market power. So all we're going to do now is we're going to fill out this table, okay? Recognizing the definitions of each of these terms in the top row here. All right, so let's go ahead and do that. So total revenue we know is price times quantity. All right, so if we wanted to fill out these values here, all we're going to do is take the first column and the second column, and we're going to multiply them together. Okay, and that gives us the total revenue for any level of production that we're going to generate. We can also compute the average revenue fairly easily by taking that total revenue value, right? Let's say $20. We divide it by the quantity sold, which would give us an average revenue of $10 per unit. And you'll notice as we move down and we do that same calculation, the average revenue does not change either, as we had seen earlier when we had defined that term. The marginal revenue in this diagram looks a little funky. You'll notice that last column is kind of staggered in terms of the rows not lining up perfectly. And that's because we're going to think about the marginal revenue as we move from one unit to the next. So for example here, the total revenue, if we go from producing 0 to producing 10 to producing 1 unit, increases $10, meaning the marginal revenue of that first unit is exactly that $10 increase. If we were to sell the second unit, you'll notice that pushes total revenue up by another $10, meaning the marginal revenue of that second unit also had to be $10, so on and so forth. So we can pretty quickly generate now the marginal revenue schedule in the right-hand column here. And note that in this example, the marginal revenue of every unit is equal to the price of that unit. And that should make sense, right? If the price is constant, you know, and it's $10 for every unit, what is the revenue I get from selling one more unit? It's got to be also $10. So I think that hopefully makes some intuitive sense here, that the marginal revenue would be equal to the price. But when we get to the case of monopoly, this actually turns out not to be the situation when we have market power. And that is because if we face a downward sloping demand curve, not a flat one that it looks like we're facing here where the price is constant no matter how many units we sell, then selling more units actually requires we lower that price, meaning we sacrifice some revenue on other units that we could have sold at a higher price. But we're not quite there yet. That requires us to incorporate market power or bargaining power into our model. And again, unfortunately, the perfectly competitive framework has assumed that away through those assumptions 1 and 2, that the markets are very large, there's many buyers and sellers, and that the good being sold is homogeneous, is similar, very similar product, almost a perfect substitute. So let's talk a little bit about the competitive firm here. And we know that the marginal revenue should equal the price for a competitive firm. And a competitive firm can change its output level without affecting the market price because it is such a tiny entity. Meaning a 1 unit increase in Q is going to cause revenue to rise by exactly the price of that good, which is why, and we saw this mathematically in that example, that the marginal revenue is equal to the price. And again, this is only true in this competitive market framework where the firm does not exhibit any market power. Okay, when we add more market power, the marginal revenue and the price will diverge from one another, and generally we'll see the price tends to be higher depending on the type of pricing scheme that the firm is using. So let's go ahead and take a look at the profit maximizing decision of the firm. So the choice variable in this problem, I think is fairly easy to think about. The firm can't really affect the price. So the only thing the firm can really think about in terms of trying to optimize here is by thinking about how much it should produce. What's the right production level? And to answer this question, we are going to apply some marginal analysis here. And the argument is going to be that if we are maximizing profit, okay, there's some condition that has to be true. And we're going to argue that that condition relies on measuring the benefit versus the cost of a small change in your production plan. For example, if we were to increase Q by 1 unit, we know we get some marginal revenue, right? MR goes up, but there is also some cost associated with that unit. Okay, and if the benefit, right, the marginal revenue is the benefit to the seller, if that exceeds the cost, okay, then what's the right decision? Well, then in that case, we should go ahead and produce that unit because it will generate a marginal profit. The revenue on that unit exceeds the cost on that unit, which means we made a profit on that unit. And if we add that dollar value back to how much profit we had made in total already, that causes our total profit to go up. Conversely, if the marginal revenue of the unit we produced is lower than the marginal cost, that means we produced a unit where the cost did not justify the benefit, right? The cost was larger, which means that unit actually caused our profits to go down because we would make a negative profit on that unit. So if this is the case, if MR is smaller than MC, then in order for us to reduce profit, we actually want to undo that production of that unit. We want to make sure that we don't produce that unit. So if MR is smaller than MC, generally what that means is you've probably produced too much. You've produced units where you were making a loss. And the easiest way to increase your profit is to just not produce the units where the cost was not justified by the benefit here. So let's go ahead and look at another numerical example derived from an exercise that we looked at earlier. So recall we had our total revenue column here. This total revenue column we got from our last example where the price of every unit was $10. Note that the marginal revenue is equal to the price here. So again, this $10 corresponds to the marginal revenue on unit 1. This $10 corresponds to the marginal revenue on unit 2, so on and so forth. So all we're going to do now is I'm going to give you a little bit of cost data. All right, so here is the value of the total cost schedule in this example. And as we would expect from our discussion of technology and cost, moving down that row, the cost tends to increase. Okay, and note now, at every single level of production, we can compute the profit if we wanted to. But before we do that, let's go ahead and look at the marginal cost. So as we move from 0 units to 1 unit, right, what was the change in the cost? Well, the change in the cost was $4. And we can go ahead and plot that here and then do that same calculation all the way down this column. And there we go. So we have our marginal cost schedule. And if you look at the profit column, okay, the way we can calculate profit is we're just going to take the total revenue minus the total cost. So we'll take this column on the left, subtract from the total cost column on the right. So then we would get a -5 right there in that profit box. And we would do that same calculation all the way down that column here through all those rows to compute the profit. Now notice the firm's objective is to maximize profit, and it looks like the maximum profit is occurring here at a value of $7. That's the most profit we can make, which looks like we should be producing either 3 or 4 units to achieve that goal. And the way that we're going to think about identifying this maximum profit allocation without actually having to calculate it is by doing the following. We're going to look at the marginal revenue, which we argued was the benefit of selling another unit, right? So that's our benefit there, green arrow. And we compare that to the marginal cost, which was the cost of selling that particular unit. And you'll notice for a large portion of units here, specifically as we look at units 1, 2, and 3, the marginal benefit in terms of that marginal revenue exceeds the marginal cost, right? 10 is bigger than 4, 10 is bigger than 6, 10 is bigger than 8, meaning on every one of those units, we can make some marginal profit. Okay, however, once we get to our 4th unit, you'll notice the marginal benefit in terms of that MR value and the marginal cost, they are the same. Okay, which means we effectively break even in terms of the marginal profit on unit number 4. We're making a little bit of profit on every unit, but unit number 4 we break even on. And that corresponds to our maximum profit allocation here, which occurs at 4 units and generates a maximum profit of $7 here. Okay, so if we filled out that last column, just the difference between marginal revenue and marginal cost, you can see now where those things are no longer different, where MR equals MC, that is what defines the profit maximizing allocation for us, which would be to produce either 3 or 4 units. But we said 3, we should move a little bit farther between here. So really we want to end on the unit where we're just breaking even. So we will produce 4 here in the profit maximizing solution. Okay, so the logic here is the following again. If MR is greater than MC, right, then producing more will raise profit because the benefit exceeds the cost on that next unit. But if MR is smaller than MC for any unit, then we want to cut back that production because the cost is larger than the benefit. The benefit is not justified by that excessive cost here. So diagrammatically, okay, what are we doing? Well, we're looking for the allocation or the marginal revenue is equal to the marginal cost. So the logic here is the following. If we are profit maximizing, okay, if we're at the top of our profit mountain, we're doing the best we can, then MR has to equal MC. Right? It's like if I am in California, then I must be also in the United States. But it's not really a two-way street. And if you take a more advanced theory course, they would get into what is known as the second order condition of optimization. Right now, we're only looking at really a first order effect in terms of the change in profit here. So all we're doing is applying this rule. We're going to graph our marginal revenue curve, which we're going to think about here really as like a demand curve. Okay, that MR curve, that is like a demand curve, but it's from the firm's perspective. Okay, it is from this perfectly competitive firm's perspective. And again, that flat demand curve there, right, that reflects the fact that no matter how much we produce, the price always stays fixed. So if we try to like restrict output to create a shortage to try to jack up the price, we can't really do that because, again, as a firm in this model, we are tiny. Okay, lots of other firms, market output is huge. We are just a drop in the ocean. I'll go back to the analogy there. Now, note at this value QA that we're looking at here, okay, why is it possible for us to improve profit? Okay, well, the marginal revenue exceeds the marginal cost at QA, which means if we produce a little bit more, we'll be able to raise profit. Okay, so QA cannot be profit maximizing. It's not the highest profit value we can make there because we just argued it can go up, right? So if you're climbing a mountain, you know, how do you know you're at the top? Well, if you move in any direction, you're not going to be able to move up the mountain anymore. And what happened here? Well, we were standing at QA and we just argue we can move a little bit to the right and we will go up that profit mountain. We will make an additional marginal profit. However, at an allocation like QB, okay, I'm going to argue that we've actually produced a little bit too much. Okay, the marginal cost exceeds the benefit, the marginal revenue from the seller's perspective. Okay, which means if we did not produce that unit, we could undo a loss that we were making on that unit, right? And by cutting back on a unit where you would have made negative profit, that will cause your profit to go up. All right, so we've just argued if MC is smaller than MR, you want to move to the right and that'll move you up the profit mountain. If MC is bigger than MR, then you want to move left and that'll move you up the profit mountain. So if you're at the top of the profit mountain, then it cannot be possible to go up any higher, which means MC cannot be bigger than MR and MR cannot be bigger than MC, which means when we're maximizing profit, it must be the case at an output level like Q1 that MR equals MC. If we moved away from Q1, then we'd be back in one of those two cases, either this case here where marginal revenue is greater than marginal cost. And what do we want to do in that situation? Well, we wanted to produce more. Okay, in this situation, marginal revenue was less than marginal cost, and there we wanted to produce less. So what we're looking at here is a slightly different type of equilibrium. I think we've used this term before, but again, an equilibrium is a situation in economics where an agent or multiple agents do not want to change their action or do not want to change their decision. They're content with the action they are taking given their economic climate. And at quantities like QA and QB, we argued the firm is not content. It would want to change. It would want to move closer towards Q1. But at this output level Q1, okay, the firm is doing the best it can, and it has no incentive to deviate from this particular plan of action. All right, so the way we're going to identify how much a firm should produce, given that the firm's goal is to maximize profit, is by applying this rule, MR equals MC, which is also equivalent to the rule P equals MC. And this is the same as the rule P equals MC. Both of those things will correspond to the firm's profit maximizing allocation. Why is that true? Well, it's because MR and P are the same for a perfectly competitive firm. Okay, now, what happens when prices change? Well, we know, right, law of supply tells us when the price goes up, firms will respond to that by producing more. And we can actually see that here in this diagram, right? Given this upward sloping marginal cost curve that we're looking at here, right? It's an upward sloping marginal cost curve, which we expect to happen, right? The more we want to produce, okay, the more laborers that requires, and those laborers eventually start getting crowded in that factory unless we also expand capital investment. But right now we're going to consider the short run analysis where capital is fixed and we can only change that variable input. Okay, so if the price were to rise up to P2, okay, then all we need to do to think about how the firm would reoptimize is by reapplying its profit maximizing rule here, where MR equals MC. And you'll note at this new point, the firm now has an incentive to produce a higher quantity. Okay, the MC curve, again, is going to determine for us, right, anywhere along this MC curve is going to determine essentially the output level we should be generating. Okay, that being said, that means that the marginal cost curve, and we'll see it's really a specific part of the marginal cost curve, okay, is essentially the firm's supply curve. All right, so when the firm needs to figure out how much should I produce, we really just need to look at where's the price, where does that hit the marginal cost curve, and that will identify the quantity to produce that is consistent with profit maximizing behavior. Okay, now, if we're in the short run, that means we've built our factory, we're operating, and I can't just pack up and leave the industry if I'm not profitable here. Okay, so there is something known as a short run shutdown rule, okay, that is associated with us essentially turning the lights off on our factory if market conditions are not favorable. Okay, in the long run, if market conditions are not favorable, then what can we do? Well, if we're in the long run, there's a lot of time that can pass. We actually can tear down the factory and totally sell off the operation. But in the short run, all we can really do is we can turn the lights off. We can tell all the workers to go home. So a key difference between these two is if you are in the short run, you're still paying your rent on your factory, right? You're still paying that fixed cost. Okay, the fixed cost of production is independent of how much you produce. So even if you shut off the assembly line and you don't produce any units, you're still paying the fixed cost of your factory, independent of the amount you produce here. In the long run, however, you can recover those fixed costs, right? In that there are no fixed costs in the long run. Everything is variable. So there is a slight difference between the implications of shutting down in the short run, where you're going to eat this fixed sunk cost, versus exiting in the long run, where all of the costs are variable. So we're going to go ahead here and look specifically at the firm's short run shutdown decision. And then we're going to come back to thinking about what happens in the long run when firms can enter and exit the market freely, given that market conditions incentivize them to do so. All right, so a firm's shutdown decision in the short run. Okay, let's think about what they give up. If we shut down, we give up all that revenue that we could have made. However, there is a benefit of shutting down, okay, and it's not the fixed cost. We're unfortunately hooked on that fixed cost. We're paying that whether we shut down, we turn off the lights or not. Okay, I still have to pay that rent on my factory. But one benefit of shutting down is we avoid the variable cost of every unit that we are producing. Okay, which suggests we should shut down if the benefit of shutting down exceeds the cost of shutting down. So if the amount of revenue that we're making per unit, the total revenue, does not cover the cost variably of the ingredients that we need to produce what we're producing, okay, then we don't really have any business being in business. We should turn the lights off and wait for maybe market conditions to change, for the price to go up, where our revenue does justify that variable cost of production. Now, this condition here, we can change a little bit by dividing each side of the equation by Q. And if we do that, total revenue divided by Q, that'll turn into average revenue, and variable cost divided by Q will turn into average variable cost. So we can restate this shutdown decision really the following way, right? Total revenue over Q is average revenue, which is just the price. So the firm should shut down if the price on every unit doesn't even cover the ingredients going into that unit, the variable cost of that unit. If we don't, that means every unit digs us into a deeper hole. Okay. Now, this condition here also turns out to be equivalent to the following. If we subtract the average variable cost to the left and multiply the entire thing by the quantity, okay, then this condition turns out to be we should shut down when our producer surplus is negative. That's an equivalent condition here. We would shut down if the producer surplus is negative, right? Producer surplus is just the difference between total revenue and your total variable production cost here. Producer surplus does not actually account for fixed cost, just the variable cost component. So this should make sense, right? Producer surplus is the way we've been thinking about quantifying the producer's piece of economic pie. And it says here, if they're going to get a negative piece of pie, which shrinks their whole profit together, then they should just avoid that entirely and shut down, turn off the lights. All right, so let's go ahead and take a look now at the competitive firm's short-run supply decision, given the shutdown analysis that we've just discussed here. So note that there are a whole set of allocations, and we've drawn here our two cost curves. We have the average total cost curve right here. Okay, and we also have our average variable cost curve. And remember, that's going to be important because the AVC is the relevant cost in thinking about whether or not we should shut down. So to be clear about that, you could be making negative profit, but still be covering your variable costs. And in that situation, you would still want to stay in business. And you're like, well, I'm making a loss. Yes, but that's the least loss you can make. You're minimizing your loss by behaving according to profit maximization. Now, you'll note also here that there is a very particular part of the marginal cost curve that is above that shutdown point. That is the portion of the marginal cost curve that is going to be relevant to us if we are in business, right? If we're in business, that means the price must at least be higher than the minimum of the average variable cost. So as long as our profit maximizing decision puts us somewhere on this red region of that marginal cost curve, okay, then the firm will not be shutting down and they will supply a positive amount here. Okay, however, if the price falls below that region, then there's a little bit of what's called a jump discontinuity here. There's a big jump. And now the firm's optimal production is actually to produce zero, is to produce nothing. Meaning, what do? They turn the lights off on the factory, they send everybody home, but it's the short run, so there's not quite enough time to sell off the factory, so we're eating our rent. We're eating that fixed cost in this situation. All right, so the firm's short run supply curve is the portion of the marginal cost curve that is above that shutdown point. And again, that shutdown point specifically is this yellow allocation right here. Okay, that is the shutdown point, the minimum of the average variable cost curve. All right, now we saw this idea towards the beginning of the course that sunk costs should not affect your marginal decision making. And a sunk cost is a cost that's already been committed and you can't get it back unless you had a time machine. Okay, so sunk costs, these should be irrelevant to decisions in that you have to pay them regardless of which decision you make. A, B, or C, sunk cost is paid no matter what. And in this problem series here with the perfectly competitive firm, the fixed cost is a sunk cost. The firm has to pay the fixed cost whether it's producing a positive level of output or if it's producing a negative output. So that fixed cost should not matter in the decision to shut down, which is why it did not show up in any of those conditions that we looked at relevant to the firm's short-run shutdown decision. Now, if we're in the long run, things are a little bit different. Okay, in the long run, the firm's decision to exit is related to recovering not only the variable cost, but it can also sell off the factory and recover some of that fixed cost in this instance. So the cost of exiting the market is still the same as it was in the short run. We lose the revenue that we could have made from units. However, the benefit of exiting the market is now our total cost, right? And there's two ways you can think about this. Either we recover that fixed cost now because we can sell off our factory, or all of the inputs are variable and total variable cost and total cost are actually the same in the long run. So depending on which perspective you take, okay, if you're assuming here that in the long run, all the inputs are variable and the total cost and the TVC are also the same, then that means when we look at the shutdown decision, it's not really any different, right? Instead of total cost, okay, in the short run, what was it? It was TVC, but we're saying in the long run, all of your costs are variable. So TC and TVC would be the same thing, and you really have an equivalent condition here. Again, if we divide both sides by Q, okay, we wind up with our per unit shutdown decision here, which is an equivalent condition which says if total revenue is less than total cost, then price must be less than average total cost, meaning on average, our profit must be negative. So an equivalent condition here is we should shut down in the long run if profit is less than zero, if profit is negative, right? Note, if total revenue minus total cost is less than zero, that means total revenue is less than total cost. That is the same thing as this condition down here, that profit is less than zero, which is the same thing as saying that the average price must be less than the average total cost. If you are making negative profit, you're making a loss. All right, so we're going to go ahead and think about the firm's decision now to enter a market in the long run. Okay, in the long run, a new firm will enter the market if it sees that it has a piece of economic pie that it can take, meaning it looks around and it says, oh, look, all these other firms are making a profit. Their total revenues are greater than their total costs. So if that's the case, then the firm is going to want to enter the industry. Okay? Conversely, we're going to see in a moment that if this was not the case, if total revenue is less than total cost, well, we just mentioned what will happen. The firm wants to exit, and then we would expect the number of suppliers to decrease. Okay, and this will have some important implications on what we refer to as the long-run equilibrium. But in terms of thinking about the competitive firm's supply curve, if we were looking at the long-run average cost curve here, if this is our long-run average cost now, we're in the long run where all costs are variable, then the firm's supply curve, again, is the portion of that marginal cost curve above this red shutdown point. Okay? So it looks like this. Similar shape as what we had seen in the short run, except now all the costs are variable. So we have this long run average total cost curve to reflect that. So let's go through an example here and identify a firm that's making profit. So notice in this particular diagram here, we can use the firm's profit maximizing decision rule, which says, hey, they should produce until price equals marginal cost, or until marginal revenue equals marginal cost, and that happens here. And then what do? We identify that point and we look straight down, and we can see here that is associated with a production level equal to 50 units. So the firm is going to want to go ahead and produce 50 units consistent with this profit maximizing rule. Now, when the firm does this, how much profit does the firm actually make? Okay, that's what we want to be able to think about here. How much profit does the firm actually make? Okay, and the way we're going to do that, I think, should be pretty simple to think about. We know the price per unit is $10. We can also see here along the vertical axis that our average cost per unit is $6. Right? So if your average cost per unit is $6 and your average revenue per unit is $10, then that means you must be making $4 of profit on average, regardless of how many units you produced, right? If on average you're bringing in $10 per unit and on average it's only costing you $6 per unit, then you must be making an average profit equal to $4 per unit. Okay, what we're going to do next now to calculate the total profit is we're going to multiply that value, okay, the average profit, by the total number of units we are going to produce, which represents the base of this rectangle in magenta here. So we're taking essentially the height of this rectangle in magenta times the base of that rectangle, the height being the profit per unit, the base being the total number of units produced, and that will give us the value of the total profit that the firm is making in this situation. It's making $4 per unit times the 50 unit it sells, meaning it's making a positive profit of $200, a positive economic profit of $200. Hey, conversely, if the price had dropped due to unfavorable market conditions, okay, then again, we can do some analysis here. So let's go ahead and think about determining the size of the negative profit in this case, or the size of the loss, assuming that our AVC is lower than the price, meaning we're not shutting down in this case. We're going to pretend that our AVC is lower than the price. Let me go ahead and clear all my artwork there. So if you wanted to think about having the AVC curve in this diagram, you could do that. Okay, it's lower than the price though, so we're going to assume that that AVC curve is somewhere down here. If you wanted to draw it in, it would maybe look something like that. So note that at the output level, that is consistent with profit maximization, where the marginal revenue is equal to the marginal cost of production. Where does that happen? Well, that happens right here. At that output level, we are still covering our average variable cost if that red point here was defining the minimum of that average variable cost, or the actual average variable cost at the profit maximizing level of production force of 30 units here. Okay, so we're going to do the same thing we did before. We're going to recognize, well, at 30 units, our average total cost per unit is actually $5. Okay, note how that compares to the price we're making per unit of only $3. That implies here we're making an average loss equal to $2 per unit. So if we wanted to calculate again the amount of profit, it's going to be negative, but we can think about that negative profit as really measuring a loss. So we could do the same thing we did last time, right? We could calculate the height of this rectangle, which was the profit per unit, in this case really the loss per unit. And then we multiply that by the base of this rectangle, which again corresponds to the number of units the firm supplies, which is 30. Okay, so let's talk a little bit about market supply and a few assumptions, again, that are built into this perfectly competitive framework. So in this model here of a market, not only are the firms selling identical products, but we're assuming they are all identical in terms of their cost structure. If they weren't, then one firm will be able to outprice the rest of them in the long run, resulting in a monopoly. And that is not what we're analyzing here. We're trying to analyze the market interaction in this vacuum that is the perfectly competitive market framework here. The second assumption here is that each firm's costs do not change as other firms are entering or exiting the market. So you entering doesn't affect my costs. Okay, that's a function of my technology. And the number of firms in the market is going to be fixed in the short run. Why? Well, capital is fixed in the short run. If I wanted to enter in the short run, I can't, because I can't build my factory, can't set up. Okay, but in the long run, I can absolutely build a factory. I can buy the land, go through the escrow process, build a factory, get all the regulations done. There's enough time passing in the long run, okay, where firms can freely enter or exit the market. So if we wanted to look at the supply curve in the short run, okay, as long as the market price is above the AVC for each firm, okay, the firm is going to produce its profit maximizing quantity, which again was defined by the allocation where the marginal revenue equaled the marginal cost. And you're like, hopefully not thinking, well, I have to look at a million different diagrams now if we have an infinite number of firms. We don't. All the firms are identical, meaning the cost curves that apply to one firm also apply to every other firm. They have the same cost structure in this model of perfect competition. So at each price, the market quantity supplied, we're going to calculate that by just adding up the quantity supplied by every firm, noting that all the firms are the same. Every firm will produce the same amount. So if I know one firm produces Q and we have N firms, then the total amount produced is just going to be N times Q here. So in the left-hand picture, we have the diagram for one firm. And in our example here, let's suppose we have 1,000 of these identical firms that have exactly that same picture. Okay, at every price, we can figure out what the market quantity is by looking at the quantity supplied by one firm. So in the left diagram, that firm is going to supply 10 units to maximize its profits. And then we take 10 and we multiply it by 1,000 because all of the firms have this same picture on the left. So if one firm produces 10 units, then all of the firms produce 10 units, which is why we have this point here on the market supply curve corresponding to 1,000 units. And we can keep thinking about this experiment as the price changes. If the price goes up, what happens? Well, one firm is going to respond by expanding output. Here in this example, output goes up to 20 units for that one firm, which means if all 1,000 of those firms have now increased their output to 20 units, then that means there's 20,000 units being supplied to the market. If the price goes up to P3, again, same thing. One firm increases its supply, but all the firms are the same. So we take that one firm supply of 30 times the 30 firms, meaning the market supply is 30,000, and we're able to graph that market supply curve in the right-hand diagram. Now, I'd like to wrap up today by talking about the entry and exit decision in the long run, another component of Adam Smith's invisible hand here. And again, in the long run, the number of firms can change due to this free entry and exit process. Okay, if currently market conditions are such that existing firms are earning positive profits, okay, then all the firms that are on the sideline, not in the industry, see that and they're like, hey, they're all getting a piece of that economic pie. I want a piece for me. And these new firms are going to enter. Okay, and what does that do? Well, that's going to shift the market supply curve to the right because the number of sellers have increased. This puts downward pressure on the price and causes profits to deteriorate. And that should make sense. You have this profit pie. We're now splitting it up between more people. That effect in and of itself would cause the profit per person to get smaller, but we're also driving the size of the whole pie down because the price falls as new firms enter. Similarly, if existing firms are incurring losses, now the firms on the bench are laughing. They're not in that market. They're not making those losses. But the firms in the market, some of them can't stomach that loss in the long run, and they're going to exit. And when those firms exit, the process we just described above works in reverse. The market supply curve shifts to the left. That pushes the equilibrium price in the market up, and this winds up somewhat hedging the firm's losses and pushing those towards a positive profit level here. All right, so what we've seen here are two situations. If the firms are making positive economic profit, okay, then as we transition to the long run, this causes other firms to be incentivized to enter. Okay, meaning we're not in an equilibrium, right? The firms that were outsiders, that were sitting on the bench, they have an incentive to change their behavior, right? An equilibrium is a situation where no one wants to change their behavior. Okay, and in a situation where the firms were incurring losses, again, somebody wanted to change their behavior. It wasn't the firms on the sidelines. It was the firms that were inside. The insiders wanted to leave. Some of them did. Okay, and that cannot be in equilibrium either. So when profit was positive, right, economic profit was positive, that wasn't an equilibrium situation because outsiders wanted to be insiders. And when economic profit was negative, that wasn't an equilibrium situation because insiders wanted to be outsiders. So hopefully you're thinking to yourself, well, what condition then must define the equilibrium of this process? And that is profit must be driven towards zero. Okay, in the long run equilibrium of this entry and exit process, under what situation will nobody want to change their decision? Well, outsiders don't want to be insiders and insiders don't want to be outsiders. Everyone's content doing what they're doing. That happens when profits are zero. Okay, and zero economic profit occurs when total revenue equals total cost, or equivalently, average revenue, the price, equals the average total cost. Okay, and since firms, when they're optimizing, produce where MR equals MC, right, where P equals MC, that means two things are happening at the same time in the long run. Okay, this first condition here tells us the firm is doing the best it can. Okay, that's what that first condition highlighted in green there says. And the second condition in blue, okay, the zero profit condition says the firm must be breaking even. So the price is equal to the average total cost. That implies that price must be equal to the average cost and the marginal cost at the same time in the long run competitive equilibrium. And remember from our discussion of technology and cost that the MC intersects the ATC curve at the very bottom of that ATC curve. So in the long run, the price will equal the minimum of the average total cost curve, where firms are just breaking even, meaning no one has incentive to enter or no one has incentive to exit. Now you might be thinking, well, if I was in a perfectly competitive industry, why even bother staying in business if at some point, right, profits are going to be driven to zero? There's really two responses that I have to that treatment here. I've gotten this question quite a bit, and my first response is the following. Okay, at some point in your life, and I hate to bring you face to face with your mortality in this video segment, but at some point we are all going to die. And because I know that's going to happen eventually, does that mean that life is not worth living now, today? The answer is, of course not. Hopefully you live every day for the short run, not focused on the long run of that impending doom. All right, so one answer to this question, why even bother going into business in this type of industry, is because you can still make profit in the short run, right? As entry happens, that profit gets pushed down. But if you're the first to the table, if you have that first idea and you're an early entrant, you will be able to make some short run profits then. Now, the other thing to keep in mind here is economic profit is revenue minus not only explicit cost, which accountants look at, but also implicit cost, which accountants do not look at. Things like opportunity cost of the owner's time and money, which economists, again, are a little bit more critical of, right? When we calculate profit, we're taking total revenue minus explicit minus implicit costs. Okay, but accountants only do total revenue minus explicit cost, meaning when we're making zero profit in equilibrium, right, from an accounting perspective, the firm is still earning enough revenue to cover the explicit costs. So accounting profit is actually positive. You would be in the black there. But my other response to this, again, is that you can still make positive profit in the short run. Okay, hopefully you are living life for the short run. Okay, so I'd like to wrap up here just by concluding a few things about the efficiency of a competitive market. Okay, the profit maximizing condition here was MR equals MC for a competitive firm. Okay, in perfect competition, price was equal to MR. That is not always the case, as you'll see when we start adding market power to the model. And since P is equal to MR, the competitive equilibrium condition says that the market price has to equal the marginal cost. And again, that marginal cost is the cost of producing that last unit. P reflects both the value to the buyers as well as the marginal cost in equilibrium, meaning the last unit is not being sold at a markup. So the market price in perfect competition does provide us a very accurate signal as the true cost for society of actually producing that unit. We'll see under monopoly, though, the price tends to float above the marginal cost due to the monopolist ability to price gouge, to engage in market power or more aggressive negotiation tactics. And in that situation, the firm does what's known as engaging in a markup. They're selling a good at a price above the cost, meaning the price no longer provides us a reliable signal in terms of the actual value, the cost value of what it took to produce that good and to furnish it to the market. Okay, the other thing that we've seen before is that the competitive equilibrium is efficient in that when supply equals demand, when the price equals marginal cost, okay, that maximizes the total amount of economic pie, not just the producer surplus, but the sum of producer and consumer surplus. So we're going to go ahead and move on to looking at some market failures in the next few segments. We'll start with monopoly. We'll move on to some other topics momentarily. But again, here are some summary conditions to note, and that will wrap up this particular video segment. It was a little bit longer, but hopefully that was informative.